Okay, so this video is about the section we talked about curve fitting in class. So we started by talking about a situation. For example, in the lab, you take data points from an output of a device at uh, minute 1, your output is 10 from a device. 2, at 2 seconds, you get another value. 3, you get another. 4, you get another. 5, you get another value. So you have basically data points. But for your device, you want to define your device by a function, meaning that eventually you want to know for each output, for each input, what output you have. For example, you want to have a function like this. It looks like a ramp, so it can be, for example, uh, a function like this. That would be actually 60/5. So that would be a function like this, would define a function that goes through these lines. So eventually, you want to give your customer a function that your customer would know how your device works. So for each T, your customer would know what would be the output. So you can get that actually by having this set of data points, because Matlab has a built-in function that connects these data points together, create a function like this, and then you don't even need the data points. You would just look at the function, and for each t, for example, you don't have any value for 1.5, you don't have any output, but if you put 1.5 here, you will have a y, so you would know at that time what your y would be. So that's what curve fitting does. So it goes from the data points to a curve or a line that connects these data points, and then it creates a function for you. So how would you do it in Matlab? You go and you just type your x. So you go from 0 to 5. That's what I have here. So you go from 0 to 5. And for each second, you save your y. Again, you're sitting in the lab. For 0, you get 0. For 1, you get 10. For 2, you get 25. For 3, you get 36. For minute 4, you get 52. Minute 5, you get 59. You have set of data points, but they are not, but you want to know the function that basically defines the relation between y and x. So how would you do it? You do it with the built-in function interp1. So you define a resolution for your x, so you can have a smaller point between the data points. So depends on what you want. You can have 0.01 for your resolution, and then you define a new y. Your new y is equal to interp1 x, which is your data point, y, your data points, x2 is your x with resolution, and then you can have linear, nearest, spline, depends on what you want. So if I run this, so if I run this, I have the data points here. The nearest will just create a line near your data point. Linear would connect all these data points together with line, and then I need to have one. Okay, so this is for a spline. The spline is red. And this is a spline, which is basically a curve that connects your data points together. So you have actually a curve that defines your data set that you got, for example, from an experiment. This is one way of doing it, or you can go to your tools. So start from here. So let's say you have your data points. Then you can go to Tools, Basic Fitting. And if you want to connect them linearly, you press on linear. So if you click on linear, it just creates a line, and it doesn't necessarily go through the data point. Quadratic, you have something like this. Cubic. So it depends on the equation. The curve changes. You want to define your function that connects these data by a 6-degree polynomial. You click on this, number of data. So do you see it goes through all the data points, and it's a nice curve. Four-degree polynomial. And then you can have the equation that defines this curve. So now you know that this equation can define your device if you want to go with fourth-degree polynomial. If you want a cubic equation, this is the one. Fifth-degree polynomial. So this is a closed one. It goes through all the data points, and that would be the equation that defines this curve or line that goes through all your data points.